Hi, everyone. Thank you so much for joining us today. We have a great session for you on the latest on artificial intelligence and machine learning. So I just wanted to, welcome everybody in. Before we get started, I wanted to cover a couple of things. There are a few changes to the original agenda. I just wanted to point out, we'll be starting with a conversation on the 5 business challenges you can solve with AI today, and then moving on to a data science deep dive demo, and then an AI services deep dive demo with a short Q&A session at the end. So make sure if there is a specific topic or portion of the session today that you're particularly interested in, that you take note of the time that it starts. The other thing I wanted to cover is, again, there will be a Q&A session at the end, but if you have any questions that come up while we go through the session, feel free to type that into the Q&A functionality in the webinar. So we'll be monitoring that as we go and answering those questions. So that's a great way to get your questions answered as well. So with that, I will go ahead and pass it over to our first speakers, Elad Ziklik, who is the VP of Oracle's AI services, and Mike Gualtieri, who's the principal AI analyst at Forrester. I'll pass it on to you, Mike. Go ahead.
Thank you. And Elad, good to be here with you to talk about, I think it's both of our favorite subject, isn't it? AI?
Yeah. Thanks for joining.
Yeah, and I just wanted to start off, like, from my perspective, being an industry analyst and what we're seeing, just the state of AI. We're definitely going to get into the challenges and the use cases, but AI really has gone from sort of science fair experiment, a lot of people call it, but very quick, in a short order, in a couple of short 2-3 years, has gone to becoming strategic. So the people I used to talk to the most were data science teams. The people I'm talking to the most now, I still talk to them. People I'm talking to the most now are sort of tech leaders and business leaders who have decided that AI is now strategic. And we believe that too. I mean, when we look at our data, we've been tracking this for a few years, and we ask companies, well, are you doing AI? And it's now in the 70% range that say yes to that, but only a few short years ago, it was in the low 40%. We believe in the next few years, it's going to be, it's going to be about 100% of enterprise that say, yes, we're doing AI. But I think what's important about the conversation that we're about to have is, okay, well, what can you do with it today, and how can you do it? And part of that, I think, is doing a little bit of myth busting. And I'm gonna start this off, Elad, and then I'll ask for your perspective on this. And that is, the only way to do AI is to hire a team of data scientists who all have these remarkable PhDs in data science, statistics, computer science, AI, and they're also simultaneously like business experts or domain experts in a particular domain. And while I think there's a lot of truth to that, a number of years ago, it's not true today. And that's what we want to do, is we want to discuss, how has AI evolved? How has the tooling evolved, the services, to the point where I hesitate to say mere mortals, because but existing development teams can actually take services and build them into their applications. Your thoughts on this, Elad?
Yeah, I couldn't agree more. I started this journey, I think, probably 12 years ago, and I remember the first few times I was engaged in leading a team of researchers that were building something. It was a paradigm shift. I was like, they were building something, and I was asking, okay, when will it be done? And they were like, we'll start testing this in 3 months. And I was like, great. So in 3 months, people will start using this. I'm like, no, in 3 months, we'll start testing this. And then 2, 3, 4, 5, 6 months later, we'll know if this thing works. We need a bunch of data types and a bunch of real customer data, and then we'll tell you if this works. And this was the first time for me, I think it was 12 years ago, or 15 years ago, where I was like, this is not, this is truly research. It's like, I know, trying to cure cancer. You go down a path and you try it out, and you may be successful or more likely not. Then you try something else, and then eventually you get closer and closer. And that was how it was years ago. Like you have these unicorns, these geniuses that were trying to do this. But if you look at today, and if you look at even I'll pick on a small thing that has been running rampant around the industry in a good way, all of these digital assistants and the Siris and the Alexas and the whatever of the world. And if you look at it in the context of your small business application, what is it that you want to accomplish? Then you can use things like Oracle's digital assistant as a business user and create very proprietary workflows and skills that integrate full-blown chat experiences into your business application. For example, today at Oracle, I submit my expense report via a Slack message. Like I open a Slack message, I send the scan of the receipt, and I'm done. Like it auto-populates everything that needs in the back end. Sends the approval. I approve this via messages. And this wasn't created by PhD wielding engineer. This was created by a business user that created a skill that says, hey, expense comes in, it has an attachment, that attachment goes there, and the process is just working fluently. And I think,
yeah. And I think what this kind of, I mean, the way we see it, the way I see it in the market, and what you're describing is there's actually three ways to get an AI solution: a data science team to build it, and I think large enterprises will need that. It's just like software. There's, the parallels are there, right? They're like you are going to need some software developers to do certain things.
Yes.
But then you're going to buy some frameworks or some tools, some services that developers can build in. But then you're going to buy AI that's just built into your business software or upgraded in the next version of your business software.
Yeah. I think there are a lot of cases there are cases where you have to do the work. What you're building is special to your business, is customized to your business, and you have to have teams that are professional in doing this and building from scratch, and that exists. I think the platforms will get better at making you more productive and making this work easier to do. And I think the tide will rise. If you look at all the articles that were published by the popular media and analysts around jobs that will never be replaced by AI. Okay, you look at 5 years ago, then one of the top things that you would see was always like artists and designers and people that are creative writers and whatever. And you look at what happened in the last months with DALL-E and ChatGPT, and you're like, so maybe that's not true. Maybe AI can actually generate images, and the recent cover of Vogue was created by AI. Yeah. Yes, there was a designer that sent thousands of prompts to pick the right one and make sure everything happened, but like no artist did any Photoshop on the image to make it happen. So in that sense, I think we'll see more and more things that AI can do for you without requiring super expertise. And what's important is the business context. You need this to work in your business context. You need this to work in close to what you need this to accomplish. And that means that you want it embedded in your business application. You want your business user to be able to access these things. And while it's still imperfect, there's a bunch of things that it doesn't do. There are many things that people might not be aware of that are actually not complicated today. And you can just go tomorrow and start using it to make your business better and more productive using AI technologies.
Yeah, and I think what I often think about in terms of the progress that's been made in the platforms, the tools, and the solutions. I've been doing a lot of projects at home, and I think about power tools. I think about like a miter saw, for example. I don't need to know how an electric motor works. I don't need to know all of the mechanics and how this puts together. I just need to know how to use it. But I think, like, if you go back, like you said, 12 years ago, or actually, let's go back to 2012 when computer vision was kind of emerging. Yeah, you'd have to know a lot of details about the layers of the convolutional networks and an enormous amount of details to like get that done. Well, now there's cloud services where you give it a labeled data set, it returns a model, right? So I think that the tooling and the solutions lag a bit with the new technology, but the pace of innovation is remarkable. And that doesn't mean that there's all use cases. And I think what we want transition to now is actually talking about, well, what are those use cases that we can, that an organization can implement and overcome some challenges. So Elad, we're going to talk about 5 of these. So why don't you get us started? I think the first one is going to be visual anomalies.
So
computer vision.
Yes. So computer vision has been out there for honestly decades, but the recent evolution in deep learning technology, deep learning models, and transformer type of technologies allow what we call low-shot training. So basically training super sophisticated computer vision models, but with just a handful of samples. And that suddenly made these things extremely useful. So you can now use computer vision service like the OCI Vision service to easily annotate or identify any type of object that you care about and train a custom model for that particular use case. So we have customers that train models to count cars in parking lot. You just sit on BI dashboards to monitor traffic coming in and out of the building. We have simple services using AI capabilities to count missing objects on a shelf and automatically alert somebody on the retail floor, hey, we're out of food, or detect spills, or our construction GBU is using AI to detect security concerns around, hey, people not wearing hard hats in a construction zone or whatnot. And even Cerner, we just recently started talking about this once we've acquired Cerner, started working with us on using very simple computer vision techniques, but they are super sophisticated behind the scenes. But from the Cerner standpoint, nobody there is a computer vision expert to detect whether the patient has been lying in the same positions for many hours. And so they are more susceptible to get pressure ulcers or other unfortunate events, and automatically warn a nurse or somebody, hey, that's been 8 hours since they last moved, come flip them or come do whatever it is that is needed. And this is all out there today. A business user can use tool, UI, user interfaces to literally label the thing they care about, click on a magic button, and then a bunch of AutoML magic happens, super sophisticated deep learning algos that you don't need to know anything about, and you have a model that works for your use case.
Right, and that's a perfect example, for people to understand that it's the labeling of the training images that's where the genius comes in, right? Yeah. It's not the data science, it's not the AI, and where does that genius come from? It comes from the business expert, and when we say labeling, it's not more complicated than that. Yeah. It's simply say, because another example, I mean, I love your examples, and one that I hear all the time too is inspections. Say in a manufacturing line, right? So something rolls off the line, or it's in process in the line, manufacturing automobile, whatever, what have you, right? That the computer vision can detect that there's a quality problem, there's something wrong, right? How is it going to do that? Well, you're going to take a whole bunch of photographs, and you're going to have an expert, someone who has inspected this or know what to look for, label that data, submit it, just as you say. Boom, now you have a model. Yeah. But now, once you have that model, now you need a developer to put that in a process, in an interface.
Yeah.
But that developer doesn't have to be a computer vision expert. This is this is the level of innovation that we have now. So I think it's
I have a friend that had problems with raccoons in their backyard. So we actually used a very simple camera to automatically tag whenever a raccoon is in the backyard and activate the sprinklers. So he has like smart system for sprinklers, and apparently that solved the problem. And again, he's a developer, so he can code, but he doesn't know anything about computer vision, doesn't know anything about AI or machine learning. Just use these Lego blocks to solve his business problem.
No, I mean, if you think about infrared type of inspection from an infrared camera and stuff, all of this sort of stuff can apply. It doesn't have to be the way we think of vision. And now there's work being done in audio and I don't mean speech, because that's a whole separate subject. That's a whole separate use case in itself. But it's getting quite interesting, and it's getting much easier to do. So yeah. And I think our next use case is fraud detection.
Yeah.
Now, so fraud detection is a tough one because the whole principle of machine learning is basically you have to have examples, right? You have to have data that shows what is fraud and what isn't fraud. So I would get often inquiries from banks and people concerned with fraud, and they say, "Oh, can we use machine learning for fraud?" Well, yeah, you can, but not if you're too good. So if you don't have any fraud, it needs examples, right? But when you talk about massive organizations that have massive transactions, the chances are you do have fraud, right? So credit card, you have fraud. So you still need that same training data, but what you don't need is you don't necessarily need data scientists to custom build that, because now there's services that incorporate fraud detection, and maybe you could talk about some of the examples of that you're seeing in the market.
Yeah. So you're right. Building a very robust and comprehensive fraud detection solution is complicated. Okay? If you're a credit card company and you want to actually build something that detects frauds and works against the bad actors that are trying to commit fraud, you most likely need a team of experts, a team of data scientists that know what they're doing and whatever. But where AI can help is, in many of the cases, is just help detect, I call this outlier detection. Okay? So help you identify things that are abnormal, may or may not be fraud, that might actually require additional analysis and obviously additional data. So somebody would need to label and say, yeah, this was fraud, this isn't, this is okay, this is fraud, this isn't. But at that space, there's a bunch of technologies that are out there that are ready, that are very sophisticated deep learning type of things, but they can be trained with very, very simple data sets, time series data. We're working with, for example, with multiple retailers that are trying to identify fraud means malicious, means something intentionally bad, but are trying to identify erroneous or outlier things. Some of them are actually fraudulent. So a supplier would submit a bloated invoice for a thing, and that needs to be sifted through. Some of it is just erroneous. Some human being did something wrong when they inputted the data, or somebody thought that you ordered 100 quantities of a certain thing and then billed you for 1,000. Why? Because it's an extra zero. So it's very hard for an AI system to detect maliciousness and say, oh, look, this was intentional. But we have, for example, anomaly detection service. You can actually detect these outliers and give you the warning signs on, hey, this thing doesn't behave like all the others that look like this. I remember this from early days in Microsoft with Xbox, where when you played Xbox, there were achievements to be won. Oh, you killed 100 monsters, or you scored 1,000 goals in FIFA, or whatever. And these had normal behaviors. It takes a normal person, whatever, 5 days to kill 10 monsters, and then another week to kill 100 monsters, and another 3 months to kill 1,000 monsters. If somebody hits 1,000 monsters after 2 hours, that is wrong. Okay, that is either fraud or abuse or some cheating involved or something that is wrong. And they actually use these type of solutions, which again we now have a very sophisticated version of this under the OCI anomaly detection, to go and flag these things. And then human beings, business experts, again, domain experts, would analyze this and say, yep, this is fraud, this is okay, this is fraud, this is okay. Model gets retrained and start getting better at identifying which type of anomalies are malicious and which type of anomalies are fine and are acceptable.
Yeah, but what I like about the anomaly detection is that it's using techniques that don't initially require any training, right? So well, I mean, it's gonna look at what's normal, but not in an active way. It's gonna do that by itself.
Yes.
And I think of it like a funnel, right? So it can pick things off, and like you said, then you could get experts involved to label it, to get it better. Or it could run its course and get better. You could have the funnel could narrow down. You could have a custom model or even a rule set, or even a more traditional rule set to kick this out or not. Because I mean, say that monster thing was, it was an internal Xbox developer testing something, right? You could say, oh, well, this is indicative of a test. Don't spit that out. But I think anomaly detection is a great example of how you can start instrumenting data streams. And we're talking about fraud, but I mean, there's IT data that you could pass through there, and potentially any other stream of data that you're looking for weird stuff.
Yeah, absolutely. And we've seen this. We've been using this. Internally, for example, to detect people who are misusing compute resources in certain patterns. So those certain ways where a new user would start onboarding themselves to start consuming cloud resources, and there are certain patterns where of how Bitcoin miners would start using cloud resources. So you can start identifying certain type of anomalous behavior. Like this is not a typical user. What's going on here? What are they trying to do?
Oh, Elad, I thought you were talking about a home worker using a mouse jiggler and detecting that. Are you familiar with the mouse jiggler?
Yes.
Oh, okay.
Yeah.
Let's go on to our next use case, because we've got great computer vision use cases, anomaly detection that's very suitable for fraud. I guess what's super exciting, has been for a few years, but it's getting more exciting, is conversational interfaces for customers, but also employees, other stakeholders, text, chat, other types of voice interface. I mean, you already mentioned Alexa, and there's Google Home as well, and others. And this has the potential to be extraordinarily scalable from a customer service standpoint, from a self-service standpoint. I mean, at Forrester, we actually have, a team of analysts. This has gotten so, big and popular. We actually have a team of analysts that just cover it. So can you talk about what your customers are doing and how you help them implement this?
Yeah. So as you said, like this is everywhere, including, if I may say, not politely, where it's not even needed to be. Like there's a bunch of experiences that worked perfectly fine before somebody slapped a chatbot in front of that. Yeah. But the reason why it is everywhere is because it's gotten so much better at analyzing your intent and understanding what you're trying to do, and it's very easy for a non-expert to create, going back to how we started the conversation, to get the custom business flow that you need for your own particular business case. So I mentioned expense reports. You can now, with things like Oracle Digital Assistant, create custom skills very easily that talk about the specific things that you as a business user are trying to get from these chat interfaces, and create highly custom, that almost look like a custom application, but in reality, it's just a chatbot, like a chat flow that sits on top of a general purpose platform. And the nice thing about this is these things today can connect to any of the custom interaction channels that you work with. If you do this through voice, or you do this through Slack or WhatsApp or text messages or email or whatever it is that you use to interact with your customers or your employees, you can now put a chatbot or a conversational interface, not necessarily a chatbot, it's going to be a voice conversation interface or whatnot, on top of that, and make it do work. And the nice thing about this is that this thing is getting so much better that, like, it's not that it replaces human beings. I think most of us still, when we talk to a bot or a human, would understand the difference, but it's good enough to get the job done. Like, I remember probably a few years ago, we were working with a telco company, and they were trying to create to automate service calls in foreign languages. So imagine if you're speaking a non-say English language, I speak Hebrew. So you call the call center and you want to talk to somebody in Hebrew. So they had Hebrew speaking employees only for 6 hours a day, 3 days a week or whatnot, because it wasn't super frequent. So if you call like late at night, you'd either get an English-speaking person or not. So originally, what they've done is they put a chatbot experience on top of this, and when people called, instead of getting like a Hebrew-speaking employee, you'd be like press 3 for Hebrew, you'd get this chatbot, and people were like super frustrated. They thought they were going to get a human. They got a bot. The bot sucked. They were like, all the surveys done were like, oh, awful customer experience. This is just horrendous. And then they just flipped the switch on the presentation, and they were like, hey, look, when you press 3 to Hebrew, it's like, look, we don't have any Hebrew-speaking person on the line. You can wait for 6 hours and they'll contact you back. Or you can try our super new, sophisticated AI-powered Hebrew-speaking bot. Like, would you like to try it out? And like, some people said, yeah. Same bot, same technology, but now different set of expectations. And people loved it. They were like, oh my God, like instead of waiting 8 hours, like a bot solved my problem. I'm like, I love this company. This is amazing. Yeah. And the technology, like, is at a place where if used correctly, it can get the job done on pretty much anything that you want to go and do, versus the old IVR days where the first thing you do would say representative, get me a human being. Yeah. I find myself, whenever I have a support problem, I look for the chatbots. Like the human beings take longer. It's a more complex conversation. I have an accent, so sometimes they don't understand me. The chatbots always understand me. It's very easy and convenient to me. So I'm now defaulting to that. I like that better than talking to a human agent, unless I need something super special done.
And the technology is getting dramatically better. I mean, just with the transformer networks and even the stuff we've seen, in the last 2 weeks with ChatGPT, which is really, which is always kind of showing the potential, what the next potential is. And I think this is also an advantage of accessing these, this is one example of why accessing this stuff as a cloud service has big advantages, because the pace of innovation is fast, and you don't want big lag times
you between that. The best technology available at your fingertips under the same APIs, the same umbrella, and it just works. Like, anecdote on this: my son, I have a junior in high school. So he somehow, I don't even know, learned about ChatGPT from things that are happening in school. And like he was asking me yesterday, we talk about ethics in AI. I was like, hey, I use this thing to write an essay. Like you need to write an essay about something. Like, do you think it's okay if I submit this, or is this cheating? What happens if other kids would use the same like prompt? Like, will they get the same answer or not? So like,
I mean, Elad, do you think that that's going to be like the calculator was back in our day? Perhaps like we're saying, can we use a calculator for this or not?
This is it's not even funny. I think educators would need to adapt to this and need to figure out what are they doing about these websites, because otherwise all homework is going to be generated by these things. And because they get better and better, every kid could get a different prompt and a different answer, and it will look like all legit. Like it's not a future. It's a present that we need to start thinking of when we think about what can these things do and what industries they can modernize. I think education is one of the first ones going to come in, and I don't think we're ready for that.
Let's talk about another sort of another use case about these chat interfaces, and that is, at Forrester we call it conversational analytics. So that's basically learning from these thousands of conversations, right? Like it could be product defects, how to improve instruction, what customers want. So that's also another use case, is that this isn't just about the chat information. This information can then be analyzed also using AI to find insights that can be used in product development, support, etc.
Yeah. And we're seeing this with the evolution of natural language processing and speech understanding to where it is right now. You can be a normal developer or your normal business user, regular business user, and build dashboards that actually understand what is the feedback that you're seeing from your customers. So if I have an interaction or I send an email and I'm like, hey, love the food, but the service was awful. We're at the point where AI can automatically extract the information and give you a very structured report out or dashboards that says, hey, food is great, but service sucked. And by the way, it sucked between 8 p.m. to 12 p.m. on Tuesday or whatever. So you can get better at understanding what are your customers talking about, what do they like, what do they dislike, and not just customers, also employees, like a bunch of surveys around, hey, what's working, what's not working, can now be analyzed in minutes rather than months, which is what typically took to get all these analytics from these customer interactions.
Yeah.
And
all these use cases that we're talking about are accessible through cloud services, meaning a developer that knows how to call a cloud service, which is every developer, can access these services and incorporate them in their application.
Yes, and so every developer can access all these services, for example, on OCI for computer vision, natural language processing, speech, document, and also not just developers. So if you're a business analyst and you're using our Oracle Analytics Cloud, then these things are embedded inside that, and you can actually custom, both train and just consume these things. If you're a small business and you're using NetSuite, then all of the, for example, document AI capabilities that we talked about are there for processing invoices, for processing receipts. We're integrating those into Fusion, we're integrating those into Server. So as the months go by, you'll see that these things become embedded in your day-to-day experiences and available as developers if you want to create your own custom applications.
Yeah, and that conversational analytics that we're talking about sort of segues into our fifth use case, which is analysis of customer feedback. That's one channel, right? But we also have on-site reviews. There's emails and other form of social media. There's other form of communication, and this is a big one because it needs to be scalable. It needs to determine sentiment analysis. There's lots of moving parts here to get the insights from that. And how are customers using that nowadays with AI-powered sentiment analysis?
Yeah, so they are doing exactly that. So the services are available today to take any type of unstructured or semi-structured data and apply AI to understand it. Okay, so this could be sentiment analysis on tweets, or this could be even more complicated thing like I submitted an insurance claim. You can apply AI to parse the claim, structure everything into a structured database, and automate what is this person looking for. Support tickets, like we see a lot of automation on support tickets, both on what is the problem, who we should we direct this to, and also what is the severity of the problem, like how frustrated is the individual that is submitting the request. And we'll also just a little tangential to this, but as we close to wrap up, what I'm seeing is a lot of interactions on just automating workflows that involve interaction with customers. So, for example, you go into a new dentist, you submit your insurance card. So today there's a human being that looks at this thing and populates a table. But we have a document AI service where you can put this and scan it, and that's it. Like all the information is now structured. And you can do this not just on like common objects like insurance cards or government IDs or invoices or receipts. You can do this on any type of form that you have as part of your engagement. Loan application, student application, whatever it is that you have for your business, you can actually very easily use AI to automate the workflow, to automate the ticket, to automate the support request, to automate the onboarding request of new employees. Yeah, this is something we're seeing surging significantly in the industry.
Yeah, and it's interesting you mentioned like the extracting information from documents. That is way more than OCR these days too, right? Optical character recognition, because now with computer vision, you can actually look at a document and maybe find signatures and find lines and structure. Yeah. In combination with maybe some more traditional OCR techniques. So it's getting interesting. And you said something about like the workflow, and you're giving the dentist example, and it reminded me that we can actually use these in combination, right? These services we were talking about in combination to create an even more intelligent flow. So we've been kind of talking about them in silos, enormous valuable separately. But together, you can kind of imagine an entire AI process. But you could start with just one, right?
Yeah, absolutely. I look at these as Lego blocks. and I look at some of the higher level AI capabilities that we talked about as the Lego kits, the Lego Eiffel Tower, the Lego Death Star, the Lego whatever. So if you're a developer, you can build anything that you want from these individual Lego blocks. But these capabilities are now at a point where if your business problem is building a Lego Eiffel Tower, then like there's a kit for that makes life much easier for you. So there's a kit for understanding documents. It uses NLP and computer vision and a bunch of custom technologies. But if this is your problem, go use the Lego Eiffel Tower and you're off the races. You'll be productive in minutes. And this is true for general purpose stuff, and it's especially true, at least for us in Oracle, for healthcare. We are significantly investing in modernizing healthcare using these AI technologies. I mentioned patient observation and care, but also like all the financial revenue, insurance type of work, as well as clinical. And there's a lot of Lego kits to be built in there that will truly change how this thing is operated and how you feel it as a consumer.
And that kind of brings me back to the start where we said, well, look, you can buy these, you can use these services to add them to your, but increasingly you can buy like no assembly required because it's in your next version of your, of your business, of your point of sale system, right? It's in the next version. And this sometimes can be stress. I think this is stressful for some enterprise buyers, or it should be, right? Because they find this brilliant AI use case. And it's that thing where it's like, well, should I implement this? Maybe. You've done the ROI, you know it's going to be good, but you better talk to your business application vendor to see if they have it roadmapped, right? Because nothing's more frustrating than to spend like 6 months building this thing.
Yeah.
Oh, the next version had it in the software. And that's happening so much now. Like every ISV, they're just like the end users, the end customers. They are looking at incorporating AI no matter what business software they develop. They're looking for opportunities for AI. So customers are going to have this full range of intents building, assembly, the Lego method, and then just the buy. So I think we also wanted to talk about a little more about the custom models, because we did say up front that it's just like software development. Sometimes there's some differentiated custom stuff that's maybe pushing the limits of innovation, particularly for your. And I think the point there is that is also getting easier. That the details and the tooling is getting abstracted away from the lower level stuff, which gives more people. A bigger scope of people are able to actually create these models.
You're absolutely right. You need, and we spend a significant amount of time at Oracle, shameless marketing plug here, to build the platform that starts from AI infrastructure. So like if you truly are an amazing expert and you need just farms of GPU that are very talking to each other very, very efficiently, then OCI is the best place for that, for large-scale GPU-powered inferencing and training, especially training. Two, I'm a small team of data scientists, and I want to build some specific custom model. That's all I need. Do you have the infrastructure? Yes. So OCI Data Science is the infrastructure that allows you to efficiently build, manage, deploy, and monitor your machine learning models, all the way to, as you said, like the assemblers, the people that want these building blocks, and they would create the experience, all the way to creating a truly embedded experience inside SaaS application that is also still customizable, and you can interact with it even at that level and say, hey, in my case, this is what I want to do, but I want to do this in the context of the business application. And
I can imagine using your sentiment analysis service, right? And it outputs and it says, oh, this sentiment's negative. But then I can imagine the data science team building a model that then looks deeper and then maybe determines what to do about that. Should we route it to a team for action? Should we ignore it? That sort of thing. So used in combination to create, AI solutions. That's what I think AI development teams need to do. They need to see everything and then figure out what is the fastest, most effective way to implement more complicated solutions.
I think that's actually a great segue. Thank you both for joining us today. I think it was a great conversation. We're at time now, so we need to move on to the demo portion. And the first demo will be on Oracle's OCI's data science platform. So we will have Elena Sunshine and Wendy Yip delivering the demo for the data science platform. And again, thank you both, Elad and Mike, for joining us today.
Thanks, Mike. Thanks, Elad. Really set us up well for our next topic of discussion. To introduce myself, my name is Elena Sunshine. I am Director Product Management for OCI Data Science. I'm going to share with you a bit of a introduction and orientation towards the OCI Data Science service, and then I will tag in my colleague Wendy, who will show us a full end-to-end example of how you would build, train, deploy, and manage a custom machine learning model on OCI Data Science. So, getting us started, I want to kick us off just with an overview of what the OCI Data Science service is. OCI Data Science is a platform for those expert data scientists to build custom models on OCI using a managed platform that gives you automated workflows and connects the OCI core services together in a way that works really well for data scientists to be able to build, train, deploy, and manage their own custom machine learning models. So the platform is part of OCI. I will walk you through the console in a moment. It is targeted to really the core data scientist persona who wants to use their favorite open source Python tools and frameworks to develop their own custom machine learning models from the ground up. So you can think about frameworks like TensorFlow, like PyTorch, like scikit-learn, XGBoost, really across the range of classical machine learning and statistical methods, all the way to deep learning frameworks for training all sorts of different models for various use cases. So our customers will have business problems in their organizations. They may be able to take advantage of the pre-trained models that you'll see from our AI services. They can combine those together in a variety of creative ways, but they may run into a situation where they need to actually create their own thing from scratch. Something out of the box is not going to meet that use case fully. And this is really the platform that they're going to go to be able to develop those models. Now that's on the development side. We also really focus on the deployment, productization, and management of models. We really encourage and provide tooling and a platform for our customers to take advantage of MLOps best practices. Now, what is MLOps? MLOps is the process and best practices, procedures, tooling, automation that a data scientist or ML engineering team would need to take any model, whether it's a fully custom model that they built from scratch, or it's something that they're pulling off the shelf, and get it into their production workflows. They need automation, they need risk management around those models. They need to be able to track and upgrade those models over time. They need to be able to monitor those models. How are they performing in their production setting? Are those models drifting? Are they losing predictive power because the data that they were trained on, historical data, the reality of today may not be perfectly reflective of the historical data that a model was trained on. So models need to be constantly monitored for performance so that they can, a data scientist or a machine learning engineer or a developer can be able to quickly assess the performance of a model, get alerted and notified when their model is starting to lose a certain amount of predictive power, and then be able to retrain and refresh that model in production. You never want to have a model out there that's working in a production setting that doesn't have any sort of monitoring attached to it. You may be giving bad predictions, and you'll need to be able to have some automation and some real-time monitoring of those systems to be able to be make sure that those models stay healthy in production over time. The platform is designed not only to help individual data scientists to develop their models, help teams of data scientists to get those into production. It's really about collaboration amongst those teams. It's not just one person that is going to take that model from start to finish. Data scientists that we're working with are typically on large teams. They want to be able to collaborate amongst the data science team. They want to be able to share and reproduce data science assets. They want to be able to take someone else's analysis and be able to rerun that and get results that they can validate against their teammates' work. They want to be able to take their teammates' innovations around new features that they've developed and be able to input them and embed them within their own custom models and take advantage of new innovation across the team. So this collaboration and sharing story is really important amongst the data science team. It's also really important when it comes to collaborating with other types of folks in the organization, whether they're business analysts that may be working more in a BI or analytics tool set to be able to take advantage of the work that a data scientist has done, and vice versa. The data scientists be able to take advantage of the analysts, data sets that the analyst has prepared or insights that the data analyst wants to go further on with machine learning techniques. And then, not only the analyst persona, but also the engineering organization or the site reliability engineers, the folks that are actually going to take those models, put them inside of a production system and keep that system running healthy. That's another key component of this collaboration and shareability story across the platform. My fifth bullet on here, running large scale workloads. We've heard a lot in the fireside chat earlier today about vision models, about large language models like, examples like ChatGPT, like the DALL-E model. These are huge, huge models that are trained on ginormous corpuses of data. And you need a lot of power, compute power, to be able to train those models and then, of course, deploy them for inference. So the platform takes advantage of OCI's strength in the high performance computing sector, our partnerships with NVIDIA, the GPUs and the bare metal GPUs that we have on OCI. The platform enables data scientists to take advantage of those, for example, bare metal GPU clusters in a lower skill level than you would need if you were interacting with them directly using the core compute APIs of OCI. So it's really about giving data scientists easier access to really high-powered compute so that they can train their own custom large-scale workloads and then, of course, deploy them for inference on the platform. And the last bullet here, you pay only for what you use. This is really about what our billing model looks like. So everything on the service, when it comes to your training workloads, your model building, your notebook session workloads, your model deployment workloads, all of those workloads that actually run compute and run storage, you only pay for the core infrastructure that you're using on demand with no additional tax or standing overhead. So when you provision something on the data science service, you have full control over exactly how much you're being billed for that. You don't need to have a standing cluster that you're running all the time that's driving those meters and pulling down your credits. There's just what you use on demand with no additional price on top of the price that's charged for the core compute or core storage or the core infrastructure itself. Okay, with that, I am going to walk you through, I'm going to take the opportunity to kind of address the right side of this picture by actually showing you the console directly. So you get a good understanding of the different feature set that we have today and how they all fit together. Me switching over my screen share. Okay, you should be seeing the homepage for the OCI console. So let me know if you're not seeing it. This is the page that you'll land on when you navigate to cloud.oracle.com. This is where you can navigate to the OCI data science service. You go into the left side hamburger menu. You'll see a menu for analytics and AI. And under the machine learning section, you'll see a service called data science. When I navigate to the data science service, I land on the homepage for data science, which is the project screen. So everything in the data science service is organized into projects. So as a data scientist, I can create a project for a specific business question that I'm trying to answer. And I can use that project to organize my work and to invite my collaborators in to see the progress of that project. So here's an example. This is my employee attrition project. When I click on that project, I land on a page, a list of my notebook sessions that I have running in the past in this project. A notebook session is a set of compute, storage, networking that is all running in a managed way behind the scenes. And all the data scientist needs to know is that when they create one of these, they can get a Jupyter Lab interface where they have the ability to code in Python and be able to use the frameworks that they love to build and train a model. So creating a notebook session is very easy. I can give it a name. I select my compute shape that I would like to run this on. So I can use something, let's see, like in the flex shapes, you can actually make this quite small. You can just have one OCPU, or you could scale this up to a much larger machine by toggling this slider. This would give me access to a much bigger machine if I need it. Similarly, there is an option for the bare metal machines, smaller or larger bare metal machines of different generations. So this is the P100 NVIDIA, this is the V100 NVIDIA GPUs, and this is the A100 NVIDIA GPUs, and this is the A10 24 gig GPU. Data scientists would come in here. They need to know a little bit about what they want to do with this workload in terms of the scale that they need. However, after the fact, if they realize they've created a machine that's too large or too big, they can scale this up and down over the lifetime of their notebook session without losing their data or their progress. Okay, the next is some block storage. You can you add a bit of block storage on this just to be able to store your environments, your data, your code, whatever you need on persistent storage is going to land on that block storage device. And then the next thing that the data scientist will configure is their networking. We provide a default networking option. This just gives you, easy access to the internet, the public internet, and the OCI services. Or if you have specific needs to access data that's locked down in your own VCN or subnet that is managed by your networking administrator, you can choose the custom networking option to be able to access this data. This is really powerful because it allows you to be able to access your data anywhere. So the data science services, of course, we support all of the Oracle data sources for data access, Oracle database, OCI object storage, the automated the autonomous data warehouse. All of these and more are options within OCI, but you can also access your data on-premise or in even another cloud, as long as the network that you select here has networking access to that data source. So once I've configured my storage, my compute, and my networking, you can click create and you'll create a notebook session. I have one here running already that I can quickly open. And once I land on this page, you'll see the metrics. You can monitor the CPU and memory utilization of your notebook session over its lifetime on this page. And when I click the open button, I will land on a new tab, which gives me my Jupyter Lab interface for my notebook section. And here I am on it. I land on the launcher page. The launcher we've customized for our service to highlight a few features that I'll just show it briefly here. The first really important extension is called the Environment Explorer. This Environment Explorer gives you a way to discover and list all of the content environments that our service has made available to our customers. So we provide a curated set of environments that have your favorite open source Python packages pre-installed that you can easily install through our command line tool. So this Environment Explorer shows you all these content environments, and the really key critical thing about content environments is that you can use these across the whole service. So when it comes to your model building, your model training, and your model deployment workloads, you can share the same exact environment. So you know that all your dependencies are there, they're at the right version, and your model is going to work the same in its training environment as it does in its deployment environment. It sounds trivial, but it's actually a very complicated thing to do right. And this feature makes it a lot easier for our customers. One note here is that we provide a bunch of these curated content environments, but as a data scientist using the service, you can customize your content environment for your particular workload. So you can just use exactly the packages and versions of those packages that you want, that you need. And we have a partnership with Anaconda that provides those packages in a curated way with all of the licensing approvals that you would need. So you don't need to worry about using the Anaconda packages for their commercial purposes. We take care of that through our licensing partnership with Anaconda. So that is the Environment Explorer in a high level. The next extension that I wanted to just highlight is the Notebook Explorer. These are a bunch of kind of getting started, nice documentation and sample use cases that are curated in these example notebooks. So to open up an example of a notebook, you can just click this open button. You'll create a copy of that notebook in your environment. And this is, for example, a way to get started quickly using XGBoost on the Rapids framework, the NVIDIA Rapids framework. So in combination with the Environment Explorer, where you can actually easily install, for example, Rapids, plus this example notebook, you can get started very quickly and jump into your work very quickly on the service in a notebook session. Show you a lot more detail on these in the following demo that Wendy's going to take over. So I'll leave notebook sessions there for now and show you the rest of the platform. The next item on the menu here is the jobs feature. Jobs are really all about doing large scale batch workloads that you would want to do in a repeatable fashion. So the paradigm here is define once, run many. You can define, for example, in this job, it's a model training job for my employee attribution or employee attrition model. This will run a model training job in a batch approach. And at the end of it, it creates a trained model, which I then save into my model catalog, which I'll show you in a few moments. So you can see in my job, I have multiple job runs. So I'm running this many times. This is great for workflows where you might have to train a model on a regular cadence to refresh that model. You could also use this for ETL. You could also use this for batch inference workloads that you would run on a regular cadence. Pipelines, this is a feature that is coming soon. It will be in GA in the next month in January. Pipelines are basically an add-on to our jobs feature. Pipelines allow you to string together tasks in a pipeline, in a DAG, that you can run on a repeated basis for automating your data science workflows. So that could include, accessing your data, preparing your data. Then it will create let's just look at this example. Like we have a data processing step. We're training multiple models, and then we're evaluating and deploying the model within this pipeline, just as an example. And then you can run this pipeline again on a repeated basis based on any number of triggers or schedules that you may have for that particular use case. Next is our model catalog. So once you train a model, either using a notebook session or a job or a pipeline, the output of that is a model. The model itself has two components, an artifact component. So this is all of the files and the serialized binary that actually comprises the state of that model and allows you to run it and deploy that model. And then the other portion of it is actually the metadata about that model. So I'm just picking a random one here. This particular model, I can see the provenance of this model. It was trained through a model training job by myself on this day. It has this taxonomy. I've chosen a bad example here. Hold on, we choose an active model. This is the one. So this gives me, I trained this model through my notebook session on this day. It shows me what code I was running to actually create that model. It shows me the taxonomy of my model, any custom model attributes that I define in my training script. It shows me if this model is deployed. So this model is deployed as a model deployment here. I can link to it right here. It will show me some tests that it runs around the health of this model. So it's doing some validation of the files and gives me an alert where I need to, if it's missing those files, that it needs to actually reproduce that state. And then it shows me my input and output schema as well. So this is all stored within the model catalog along with the actual model artifact itself. And this allows me to be able to deploy a model very easily. So from this, this model page, I can create a model deployment directly from the model catalog. Through another example, I can create this model deployment through the model deployments page, just again by selecting a model that's in my model catalog, one of my active models in my model catalog. So what is a model deployment is the end of the line for this model. This is where this is a deployed model that is ready for inference by an existing application. So I've got an application out there. I want to embed this model as an endpoint and hit that to be able to receive a prediction. So when you create a model deployment, all you need to do is select your model, configure the compute that you would want to be able to support the load that you expect for that model. You can add on some logging to help you out with this as well. Then once this model is created and active, you can use it again to get predictions from that model for your applications. Now, with that, I've gone all the way through a workflow, but I'm going to hand this off to Wendy, who's going to show you a real example for this employee attrition use case.
Yep. Hey, hi everyone. Let me share my screen. Can everyone see my screen okay? Thumbs up.
We can see it.
Okay, fantastic. Awesome. Okay. So hi, everyone. My name is Wendy Yip. I'm a product manager for OCI Data Science. Before I joined Oracle, I worked as a data scientist for several years. I worked in companies. I worked that range from retail. I worked in a company that specialized in enterprise software and and also a media tech company. So I'm going to walk through the employee. I'm going to go through how you would build and train a model in the data science notebook, and then also use a model deployment so you can use the model that you have created to create prediction. And I'm also going to show you how you would do the same thing, but using the data science job that we had shown you a little bit earlier. So when you log into OCI Data Science Notebook, you see that it's a Jupyter Notebook interface. You can create a new notebook very easily, and then you can pick which content environments that you want to use for your workload. So for this example, what we're going to do is we're going to use a data set that has different attributes about an employee, and then predict which employee is at risk of leaving the company based on these attributes. So large corporations often face an issue of being able to retain their talents, especially the best employees. So this is an issue that's facing human resource and also management. So being able to identify employees that might potentially leave the company can potentially benefit the HR department and also help them figure out how to better retain their best employees. So first, we're going to import the packages that we want to use. So up here, you can use so in the content environments we provide, we have already packaged up specific versions of packages that would be useful for data scientists. They're kind of grouped by use cases. So this one is the general machine learning content pack. So it has a lot of different commonly used packages for general machine learning building, like scikit-learn, pandas. So we're going to load this data sets. We're going to utilize the accelerated data science SDK. So this is an SDK that's built by a team at Oracle. It's included in our conda packs that we have. The ADS package comes with the conda packs that we provide. It's also available on PyPy, so you can download it and use it if you want to. So we're going to utilize the accelerated data science SDK because it has a lot of tools and functionalities that make it really easy for you to perform a lot of the common tasks that data scientists would use when they work through a machine learning problem. So first, we're going to load the data sets. And you can see that this data sets, it has this column attrition, whether it's true or false, and it has different attributes. So each row represents one employee, and this is the attrition is whether they left the company or not, and it has different attributes about the employees, such as whether they travel for work and what is their job function, and how long is their commute. So one of the first things you do when you work with a data science problem is you want to develop some intuition about your data sets. So you want to generate plots. You want to visualize your data sets and perhaps get some statistics about the features in your data sets. So we're going to utilize ADS to do the visualization. So we have this functionality feature plot where you can pick a specific feature and then generate different types of plots to get an understanding of the about the distribution of the specific feature you're interested in. So for example, we have this plots that shows you the distribution of employees that have left the company, which is fortunately few compared to the ones who did not leave the company, where the attrition is false. We can also look at the distribution of the age. We can get a box plots, and we can also look at how correlated the features in your data sets are. Which is important for you to decide what features you will use which features you will use to build your machine learning model. So you can also get the statistics of your feature. So this one, it's you're looking at the attrition data set. The attrition feature, which is your target, and you can get the mode, the counts, and what is the frequency of the labels. Okay, so ADS also helps you with the feature engineering. So before you can build a machine learning model, you want to figure out what are the most informative features that you would put into a machine learning model to help you best differentiates the different classes that you have in your data sets. And you might also want to do some data transformation, and also maybe build some generates like new features on your own. So ADS gives you suggestions for transformation that you can do on your data sets. You can fix, like, for example, class imbalance by up or down sampling. So if you call suggest recommendations, it'll give you actually in code a list of recommended transformation, like whether you should drop a specific columns, or if you want to downsample or upsample your data. You can also call auto transform, and it will apply automatically all the recommendations that are listed here, or you can pick and choose which one you want to do. So after you have transformed your data sets, you want to split your data sets into training and test data sets. So in the trained data sets, you actually train your machine learning model on that data sets, and then you'll reserve the test data sets for testing to see how well your machine learning model does on data that it hasn't seen. So we're going to try out a random forest classifier model, which is a type of tree-based classifier. We're going to build a model and then train it here, and then use it to see and evaluate it based on how well it does on the test data sets. So after you've built a machine learning model, you would want to save it and then be able to access at a later point in time and be able to share with your colleague. So this is actually an issue that I ran into when I work as a data scientist in the industry. Oftentimes, it's hard to figure out how your colleague managed to create a specific model that they did, what exactly they were doing, and how can I reproduce it. Often, data scientists work on their own laptop, and then it's like the visibility of like how someone generated their work, it's a little bit difficult. So using the model catalog, you can save the models and allow your team, other people in your team, to be able to get the set of model artifacts that would and a serialized version of your model, so they can recreate that model on their own and be able to test it out, and then maybe do some comparisons and experimentation. So we're going to prepare, ADS allows you to prepare the set of model artifacts that you would need to recreate that model and also serialize the model. So in this part, I'm doing that. And then if I go to the model catalog that Elena had mentioned earlier, you'll see that these are the list of models that I have already saved here. So this is the one that I saved for the random forest model that I used, that I had created for employee attrition. And then I can, after I have created my model, I can use our model deployment resource to deploy and use this model in an application. So perhaps I might want to create a web application where I can call this random forest model, and someone in the HR department might have a new set of data, a new set of employee data, and they want to see which employees are at risk of leaving the company. So in order to create a deployment, you can specify, you can just call .deploy. You can have logging enabled in here so that you can see what happens with the deployment. And then when you invoke the deployment, you can just pass in a new set of data and then get the prediction about whether this employee is going to leave or not. So now the notebook is a great environment for experimentation. You can explore your data sets. You can test out different model and then try it out and see what happens. It's a great place for experimentation, but for productionizing it and also for doing repeated tasks, you might want to use our data science job resource. So what you can do is you can define a script. So in here, I have a Python script that that uses the same data sets, and I'm I'm loading in the data sets, splitting it up into the training and testing data sets, and then defining a model and then training it. Then I'm going to save it, serialize the model and save it and upload the model in object storage. So I have this script here. When I can use jobs, and then jobs allows you to define the infrastructure that you want to run your scripts on. So you can just run your scripts, and then the compute will be spun up, and then it will be shut down afterwards. So it's really nice. So in here, I'm defining the infrastructure that I want to use for this job. I'm defining the compute shape and the block storage size, and also the logging resources that I will use so I can see what happens. So keep track of the job. I can define the scripts that I want to run it in and what environments, content environments that I want to use to run the script. So I'm actually using a custom content environments that I have created in order to run the scripts. And then after I've defined the job, I can create, okay? So after I create the job, I can see that I can run it, and you can see it, the process goes through, and then it will tell you when the job has been accepted, the infrastructure has been provisioned, and then it will let you know that the job has ended, and then compute resource will shut down. Another way you can set up a job, again, like as Elena mentioned, is you can set it up from the console itself. It's easier for me to show you all the steps in layout in the notebook environment, but if you want to, you can also define it here selecting the compute resources that you want to use and providing, defining the logging, and also what scripts you want to use to run this job. So, okay. So this is a demo of our data science notebook and job. Thank you.
Thanks, Wendy. I think at this point, we're going to pass over the mic to Luis, who's going to take us through the AI services deep dive demos.
Hi, everyone. It's a pleasure to be with you today. And today we're going to talk about AI services, as Elena mentioned. And thank you, Wendy, for that demo on Oracle Data Science. So really quickly, just so that we can frame ourselves. So on the, like we have talked about Oracle or OCI data science right now, right? So we have a set of tools geared towards data scientists. But as Mike mentioned earlier today, you don't need to be a data scientist to be able to harness the power of machine learning today. There are different layers at which you can consume machine learning. So I'm going to talk about the next layer of abstraction, which is what we call AI services. And I'm not going to be in presentation mode much longer. I just want to kind of frame you so that you are aware of that we have a variety of AI services. I will not have time to talk about all of them. We will need a lot more than 30 minutes to do that. But I want to give you a taste of the type of things that you can do with some of these services, solving real world problems. So let's actually get started. Imagine for a second that you're dealing with a lot of support tickets and you have to deal with them. Sometimes, let's say to take a particular scenario, you work in the department that is in charge of getting new hardware for your new employees. So sometimes they may write you a ticket that says, hey, I am starting February 4th. I need a Dell laptop with 32 gigs of RAM because I am an engineer. Or somebody may say like, hey, my mouse stopped working. Can you please send me a replacement? I'm working remotely. This type of problems. And maybe sometimes over the weekend, someone calls your department and just leaves a voice message. So let's take this as an example. So let's start with a piece of audio. Actually, let me share my screen again. I think I forgot to share my audio. Let me do that. Here, sharing sound. Okay, this should be better. So this is an example of a recording that, like a voice message that someone sends to your department.
Hey, my name is Robert Jones. I got a keyboard from you guys a couple of days ago, December 4th, but it's been having some problems with Bluetooth connection, not connecting properly, and just general issues. I was wondering if you guys could send in a Logitech one. I heard that those are a little bit better.
I will stop that right there, but you get the idea, right? So it's somebody calling, they're just speaking naturally, mumbling a little bit, they're on the phone. The quality of the audio may not be perfect. Not a problem, right? So I want to use Oracle, the Oracle Cloud, to help us go through this process. So I'm going to highlight a few of the capabilities of some of our services. So if you want to use our AI services from the home screen for Oracle Cloud Infrastructure, you go to Analytics and AI. And then you will see both the machine learning, or what we call the machine learning platform. So you will see like data science, which Wendy showed a second ago, as well as the list of AI services that we have available for you to consume. So let's start with speech. So speech deals with this transcription of content. So in this case, I want to transcribe, these types of audio files. So all I do is create a job, and essentially, I have already saved the files to object storage here, but essentially I can create a job, I give it a name. I'm not gonna go through the whole process to save a little bit of time. I pick where my files are. I have a speech input files folder in my object storage. And then once I have that, I can select, for instance, what language the content is in, so that we give a hint to the processor so that it can perform better in that language. And I can select if I want to get SRT transcription format. I'll select it just for fun, but this is the format that when you're watching a movie or seeing a presentation and you see the text right under, that's the format that is generally used for that, for these captions, right? So, and what that has is that it tells you exactly the time when a particular word is mentioned. So I'm just gonna do that. I'm gonna click next. I can select the files that I want to transcribe, and then you click submit to actually start running the job. This job will take about, between 30 seconds to a minute to run. I am not gonna run it because I already did that before we, before I started this presentation. So I'm gonna look at the output of that right now. Transcription job 1. And final 3 M4A happen to be the file that you just heard a second ago. I'm gonna click on it. And you can see that I get the transcription. Hi, my name is Robert Jones. I got a keyword here. Let me just to highlight, right? I got a keyword from you guys a couple of days ago, December 4th, yada, yada, yada. So beautiful, right? And I can actually show you the SRT format. So this is this format right here where it says, hey, comma. So you can see that it introduced the, whenever the person paused, it introduced commas or periods, right? My name is Robert Jones, right? So it tells you exactly the time for each of the tokens, right? Like the start time, the end time, even the confidence. How easy was it to understand the person speaking and so forth, right? So this is really cool. So far, I haven't had to do any data science. I literally just, started a job with the service. It did the work for me. Like any developer can do this, right? And if they were to do this programmatically, essentially the result that they will get from the SDKs or from calling a REST API is essentially this type of output that is very easy to parse to get the information that they need. And I'm gonna copy this in a notepad that I have next to me here, just so that I can use that later on. So, okay, perfect. And then, all right, because what I want to do is further process this so that we can get insights from it using pre-built models, nothing special. We're gonna get to custom models in a second, but you still don't need to be a data scientist. So let's go to analytics and AI, and I'm gonna select a different service now, OCI language, that deals with natural language processing. OCI language provides pre-trained models, it provides text translation capabilities, and you can even create custom models. And we'll talk about why custom models are important in just 1 second. Let's start with the pre-built models that it has. So I'm gonna analyze some text just using the console right here. So far, I haven't even had to write any code, right? So I'm just gonna copy the text that I had a second ago, and sorry, I'm gonna paste it here. And let's see what we can analyze out of the box without having to do anything custom, right? And sometimes it will do great. In some other cases, it will not. But I wanna, highlight that because those are some of the areas where machine learning, like sometimes you don't know what you're gonna get and how we can improve it or train it better. So okay, so language detection, it did really well, right? So you can see here that it was able to detect that the language was English, and this number is the confidence score. It was super confident that this had to do with language. We also support what we call text classification. So this is a pre-built set of classes that we have created, and then the system, given the text there, it will classify the content. In this case, to be honest, like the system wasn't super confident. It was only like 60% confident that this had to do with computer and electronics and software. In reality, it didn't do so great because this person had a problem with the Bluetooth stack for the keyboard. So Bluetooth, yes, there is some software aspect of it, but there is also some hardware aspect of it. So I can see why, it was a little bit lower confidence, but that's why, that's why we present those numbers to you. Then named entity recognition. So let's take a look at this. So this is super interesting. It was able to identify, Robert Jones as a person. It identified a few quantities, like, whether it was written in Roman numerals or not. It identified a few products. That's interesting, right? The Logitech product. And some dates, a couple of days ago, or December 4th, were dates that it identified. Or even an email, right? So named entity recognition has to do with identifying well-known entities, right? Names of people, organizations, locations, products, emails, phone numbers, and so forth, right? This is actually already very useful because honestly, what we usually want to do with a support ticket like this one is that we want to extract as much structure as we can, right? So that we can automatically essentially fill a form and automate the whole process. Now I know the email of this person. I know I know the name of the person. I know, that they had that they received the keyword December 4th, but I would like to go one step further. For instance, there is a quantity here, 734,795, that is not just any number. This is the cost center number. Ideally, I will be able to identify this as a cost center. Or maybe there are different dates, as the person is talking. Maybe they're saying, hey, when do they need the product to be shipped, or when was it shipped? Or when did the person start working on work, or maybe when they will start working, right? So I would like to be able to kind of decompose this a little bit further. And we're going to use custom models to do that in just 1 second. Just for completeness, key phrase extraction deals with, when you have large corpus of text, like, hey, what are the most common texts being used, most common sentences being used, terms or key phrases being used, can speak today. And in this case, it was just like 2 sentences or 3 sentences, so I'm not gonna pay too much attention to that. But think of it as automatically tagging your content, right? So it finds tags like Bluetooth connection or Logitech or general issues, right? Now, where this one really, really shined or shown, I guess, is in identifying what this person is frustrated about. Their keyword is having issues with the Bluetooth connection, right? So you can see here, Bluetooth connection, keyboard highlighted as negative, automatic sentiment analysis. For you don't have to be a natural language expert nowadays. And I really like aspect-based sentiment analysis because it gets to that level of detail. Of course, we also have document and sentence level sentiment analysis. But to me, really aspect level sentiment is really where you get the insight from this content. Okay, so let's go to the next level. How will we create a model that identifies, let's say, the cost center? What you do is you need to teach the system, but I don't expect you to be a natural language processing expert. Just like Mike was mentioning earlier, really, what I want instead is you to be a domain expert where you know what a cost center is. That's all I require of you. So what we're gonna go to another product. Oh, sorry. We're gonna go, actually, let me navigate to it right now, actually. So I'm gonna go to Analytics and AI, and I'm going to go to the data labeling service. And I have already created a data set just to save a little bit of time where I uploaded several support tickets. And for each of those support tickets, once again, all I need to know is how to label these support tickets, right? So someone may send me a written record like this one, right? Where they tell me their name, the employment, the cost center, very structured, right? In this case. And all I need to know is, hey, like send by is a ship date, right? So all I do is highlight, that's a ship date, highlight it, and then essentially generate these labels for, whatever tickets I have received in the past. In this case, I used only a handful. I used about 36 tickets or so. I didn't use a lot of data because I wanted to show you what happens, if the model is not perfect. How can you identify it? And furthermore, how can you improve it? So I'm gonna go to the next, record, and just to give you an idea of essentially, like different types of, in this case, different types of entries, right? In this case, the person is referring to the cost center by the term CC as an example, right? Okay, that's how people know what a cost center is, and then we can teach the system these patterns. So now that I have labeled all this content, I'm gonna go back to language, and I'm gonna go to projects here, and I have already created a few projects, one for classification. We're not gonna talk too much about classification today, but I just want you to know that you can also create custom classification models, and one to extract these custom entities. So in this case, to train a model, it's very easy. All you have to do is say like, hey, what type of model do I want? In this case, it's named entity recognition. Where is my data? I created a data set using the data labeling service. And you know, I called it support tickets over there. And then once I have that, I can literally just click next and then create and train the model. Once again, just to save time, I'm not gonna click create and train right now. I already did that before the session started. And this is what my model looks like. Once it's done training, essentially, you'll be able to see the quality of the model. You'll be able to see the precision, the recall, the F1 score. And in this case, because you know we're dealing with several classes, we present to you both micro, macro, and weight precision, recall, and F1 score, so that you can, you know, like they take into consideration kind of the distribution of classes. That's probably as, you know, as complicated as it's gonna get from a data science perspective. For those of us, as Mike called them, mere mortals, the bigger this number is, the closer it is to 1, the better, right? So F1 just kind of combines precision and recall. And I can see that I got a pretty nice model, 0.96. And I can see the confusion matrix where I can see, hey, how do things get classified? You know, like this is the actual value, how these different terms get predicted. I can see a few errors, right? Like, so my equipment wasn't, an actual piece of equipment wasn't classified as equipment in one case and vice versa. So maybe I want to add more entry points for equipment as an example. Okay, perfect. But let's actually try it. So I'm gonna analyze on this model, and I'm gonna enter exactly the same text that I had on the clipboard, and I'm gonna click analyze, and hopefully we were able to find. By the way, now employee is not just a person. He's the Robert Jones is the actual employee. By the way. We can see that it identified keyboard and Logitech as equipment, and the cost center, which was the other part that I cared about, is right here. Another new feature of language. So this is great, by the way. Like, this is super exciting. Now I essentially can structure all of this information. Now, but what will happen if I had some text in Spanish? Let me try something here. So I'm gonna go to a new capability that we have in language, which is text translation. And instead of translating to the other language, I'll start with Spanish, which is a language that I can understand. I'm gonna just enter some text in Spanish. And, you know, hello, it's Luis Cabrera. My printer is no longer working. I would like one that has a wireless connection, yada, yada, yada. Even if the content is in different languages, now we have the ability to translate it. So this is exciting, right? So to recall, now, if we get the text in, you know, as a voicemail or something, we can convert that to text. If we get it in a different language, no problem. We can translate it to English. Furthermore, once we have the language, we can extract the pieces of information that we care about. We have pre-built models such as sentiment analysis that will tell us what people are frustrated about. And with just a little bit of effort labeling a few records, I can even create custom models that, you know, will work uniquely for me. In this case, extracting the cost center or the ship date or the start date. Okay, let's switch gears. And I'm gonna talk to you. I'm gonna show you two other services. I'm gonna show you OCI Vision and document understanding. So for OCI Vision, we're gonna take a manufacturing use case where essentially, you know, as pieces of lumber, are coming off the planar, I would like to be able to identify, hey, are there cracks on it? Are there, like knots in the wood? And the reason is that depending on that, the cost or the value of those pieces of lumber may be different. So it's a way to classify different pieces of lumber. So, very real case. Why don't we start with this? And for that, we're gonna start by actually going to our vision service. I'm gonna click analytics and AI and then vision. And I just wanna show you that vision does have some models ahead of time, models that you can use without training any models. Of course, we don't have the would not finding model out of the box, but like let's say I have this image and I want to classify it, immediately can identify, hey, there is a road there is a transmission tower, there is an overhead power line. So so we already have several models with many labels that we have trained out of the box here. Like it's a pair of jeans, so the system hopefully will identify that that's the case. Yeah, it identified what I said, but it also identified other labels on it, like, oh, there is a pocket, there is denim, the material, textile, the waist. That's actually interesting, it's the actual waist. So it was able to automatically tag some of these images. In addition, just besides some image classification, there is the next level, which is object detection, right? So this is about identifying the actual location of the object. And in my, if I am working in manufacturing, like I said earlier, let's take this example, maybe a little bit more appropriate. Maybe I want to see if someone is wearing the, the protective equipment, in this case, a helmet or not, right? But let's go one level further, because ultimately what I care about is creating a project that uses the wood information. Sorry, I create the project is just a folder to organize my model. So I'm just gonna use the project that I already have here. So I want to create a model here, right? And what I will do is I'm gonna choose an existing data set, and you can see that I already have one called wood defect detection data set. But how did I create that? Once again, it's the same process that I showed you for language, where I go to my data labeling service, and literally I just uploaded a set of images, and for each of the images, now the task is, let's assume that there is a crack right here, right? I select that, and then I can say, hey, there is a crack right there. Obviously, the crack does not exist there, so I'm just gonna remove that one. But that's essentially the process. You can see that here I have marked that. Maybe that's, instead of resin, that should be a crack. I don't know, right? Like, I'm not the expert on wood. Someone else labeled this for me. But there is dead knots. There are some cracks. There is resin in some places. And essentially, you just take several of those images and have a person that actually knows about wood, go and mark each of the defects that they identify in the wood, right? So you do that for several images. I'm just gonna show you a couple more. Just like that, right? So like dead knot, there is a crack right here, and so forth. And then once you have gone through the process of labeling, then you save your data, your data set. And then here I can say, hey, I just want to choose an existing data set that I created in data labeling service, select the data set. And then, select like, hey, how much do I want, how do I care about quality versus time, right, of the model? So I could say like, hey, just train something in less than an hour, right? I give it a name, my new model. And then once I do that, I can go ahead and train the model again. I'm not gonna do it. I did it before this session. And I have this wood defect model, and I can start selecting upload files just to test them here. In this specific case, just to save a little bit of time, we happen to have a website that makes REST API calls, and then given different pieces of wood, right, it is able to identify the different issues. So in this case, it identified a live knot. You can see that it created a little box here, right? Then the second one here is a knot with a crack. So that's this knot, and the crack is right there. And then there is another live knot somewhere. Oh, I can barely see it, but the system was able to find it right here, right? So that's pretty cool. It was able to find things that maybe even I would not have been able to catch as a human, right? So pretty exciting. Now, that allows me to automate the process, as the pieces of lumber are coming out of the planer, they get automatically tagged, and then a system can send them into different directions using AI. We were able to do this without any deep knowledge of computer vision, without any knowledge of deep neural networks, convolutional neural networks, and all that. We literally abstracted that problem away. You don't have to worry about infrastructure problems as well. We just take care of it for you. Last but not least, I want to just spend at least 1 second on, actually 2 seconds, one on document understanding, just to bring you aware of a different service that we have similar to OCI Vision that can identify structured and unstructured content. So in this case, we have a driver's license or a passport, and our OCI document understanding can, automatically learn, like, what is this? Like, for instance, I can identify that this is the address of the person, or that this is the name. Notice that it doesn't say name or address there, right? Like, so it was already a pre-trained model. So we create pre-trained models for things that are very common, that our customers are asking for us very often. So driver's licenses from different places are a common problem, right? In that case, when you call it programmatically, you will receive, like the information, of course, in a structured manner. For instance, like this is from the Minnesota region. It was issued on August 15, 2020. And, we can show you the bounding box as we show you the actual location. And not only that, but, like, programmatically, as you go through this, right, like we tell you the classification of the document, the language that was detected in, and for instance, for each of the key values, right, like we can identify, hey, let's say issue date, just to zoom into this a little bit, right? For each value, we say like, okay, so the issue date has the value August 15, and we give you metadata such as the location in the picture, the XY coordinates for the bounding polygon that contains the issue date. So you can quickly verify and write code that takes this structured information and then does something with it. But driver's licenses are just one example. We do the same for invoices, receipts, passports. We can extract tables and text from documents. Essentially, we want to make it easy for you to work with your documents and then get the structure out of them so that you can do further processing or do automation based on the insights that you have extracted from that. And last but not least, now for real, I want to let you know that we also have what we call decision services, services that deal with time series data, for instance. So we have OCI forecasting that forecasts information, anomaly detection that helps you find anomalous data. I am just going to show you one example of anomaly detection. I'm not going to show you how I train the model just because of time, but I will show you what it does. So in this case, I'm going to go to analytics and AI, anomaly detection, and very quickly show you that I had trained our system to find, essentially with signals from 3 sensors, temperature, pressure, and volume. And essentially I can tell it, hey, like everything is working well. Learn what good looks like, right? And then I can give it, later on some data and say, hey, do you find any anomalies on this, right? Maybe some sensor, like gets disconnected, or the relationship between components no longer makes sense, right? You may remember from chemistry, you know, like the correlation between pressure and volume and temperature. For instance, if you increase the temperature of a system, the volume tends to increase, right? If not, if you keep it constant, then the pressure increases and so forth. So this is a little bit of a notebook or, you know, or textbook exercise, I should say. But I just want to give you an idea of what the system does. So right before this, I fed some data with when I introduced a few anomalies. So in some cases, you can see it identifies some anomalies in the volume here. It was very noisy. In some other cases, there were some sudden changes that it didn't expect. By the way, like there was like, you know, maybe my sensor went down for a second, right? So some things that may not be obvious to us, the system will find because it has learned the relationship between like temperature, volume, and pressure, right? And there are correlations between the variables and also kind of relationships on like, hey, how does the signal move over time? Does it have any seasonality? Is it mostly always increasing? Like, you know, what is a slope of change that is, you know, like normal versus abnormal? So it identifies all these patterns and it uses that to give you warnings so that you can take a look at anomalies later. All right, and with that, I will finish my demo. And I think we have about 5 to 10 minutes for questions and answers. I'm gonna stop sharing my screen. So I think we have to stop recording for whoever is recording so that